Hi, my name is Benjamin Troch. I work as a virtualization architect for Pure Storage in the APJ region. And I'm going to talk today a little bit about best practices for all-flash data reduction arrays with VMware vSphere. So you will come to find what that means during this session. This session agenda is we're going to talk a little bit about settings and configuration options, what you need to think about, what you don't need to think about, and why you set certain things, why you don't set certain things. Most of the information in this session applies to all vendors. So it's not Pure related, it's like, this is for all vendors. Although I can confirm that a particular vendor has that particular setting or works well with it. So it's important that you always ask your all-flash vendor, does this apply to me or not? But the majority of them do. VMware is the expert when you're talking about storage. VMware is the expert on vSphere storage settings. They work up the stack, they work up the application stack, so they are the first point of contact that you should contact when you're talking about storage or all-flash. Storage capabilities vary widely from vendor to vendor, so every vendor has different recommendations and has different ways of doing things. So always contact your vendor, so first VMware, then your vendor. Storage vendors are experts on deploying vSphere with their arrays. So some of it applies to all arrays, some of it will be specific to an array, so you always contact your vendor. We try to make this presentation as fair as possible for all vendors. This is a slide from a few years ago that Vaughn Stewart was doing a presentation together with Shad from EMC. And they said simplicity is the key to success. So what they meant is, if we simplify storage, we can have a very easy way of deploying storage. If we can simplify that, then we take away a layer of complexity that we spend a lot of time with at this moment in time in our VMware deployment. The storage layer has always been a long time, or a process that takes a long time to get your storage team to deploy a LAN, and then present it to your host, and you have to put your VMFS on it. Normally with the change control, it's easy 2 to 3 weeks before you can get a volume or get a volume extended. So 2 years ago, I think this was, they said like, use storage APIs for array integration, so ATS improves VMFS performance, use pluggable storage architectures, NMP, SATP, and PSP, and third-party MPPs. Use storage efficiency technology to reduce cost, thin data store, data deduplication, and compression. So simplicity remains the key to success. So what that means is, once you put your storage in, you shouldn't worry about it anymore. You shouldn't be tweaking it anymore. You shouldn't be going like, oh, that LAN is busy, so I have to move my VMs to another space. And this is what an all-flash array does. It takes that complexity away, and you don't have to worry about it. You just drop your VMs on there. They can be database VMs, they can be web servers. It will work. Because I was talking to a colleague of mine from another company, he said, IOPS don't count anymore. With all-flash, IOPS is something from the past. Yeah, we were limited with IOPS. Now we're not limited anymore, and the applications that we have at the moment can take advantage of the IOPS that we offer. I have customers that run a complete enterprise on 60,000 IOPS, and this is a big bank. They got one array, 60,000 IOPS is more than enough, and this is 20% growth rate for 3 years included. He says, perfect. So all these high IOPS that people say they can do are never used. For us, for example, we have maybe 1% of our customers that go over 80% of utilization. So we got too much IOPS. So that's very good, because then you don't have to worry about it, your storage anymore. You can think higher up the compute and higher up the networking. If they can do the same with networking and with compute, then you got the plumbing right. You don't have to worry about that. And then you can think higher, you can think about the application layer. The application layer is where the key to success is for an IT organization, because this is where you add value to the business. The business doesn't care about the plumbing, right? And this is why they always think, oh, these guys cost money, but like, what do they do? I don't know. I pay them a lot of money, they're all experts in something, but I don't know. Do I see a business outcome? No. If you can get the plumbing right and you make that easy to manage, automated, then you can think higher up the stack and add value to the business. And I've seen people being very successful with only doing the storage part, getting that right, because they went to all flash, and applications that used to take 12 seconds to log in was 1 second to log in the morning. So the manager goes like, what happened? Our HR system used to be like 12 or 15 seconds and now it's 1 second. What did you do? Oh, we implemented an all-flash array. And a lot of people get promoted over that. It's a very simple solution, I'm not kidding. So it's nice to see that our customers have success with all-flash array. So to change the subject, data reducing all-flash arrays are very different than disk and hybrid arrays. This is something that we found out when we started thinking about how long does it take for an I/O to be like, to go through the server, it's sent from the server, go to the storage and comes back. Where is the latency? So if you see that you got your normal storage, which is in the middle is 5,000 milliseconds, and your CPU request I/O is like 100 microseconds, you see the big gap is the storage. That's where the delay is. So when you implement an all-flash array, you can bring that down to maybe 600 microseconds. That means that you can put more CPU requests over the same period of time. More CPU requests basically means you're going to move the bottleneck where the storage was to either the CPU or the memory of the server. And that is something that you have to think about when you implement an all-flash array. It's like, what's going to happen if I take that bottleneck that traditionally is on the storage? What is going to happen when I take that away? So you're going to hit a constraint either at the CPU level or at the memory level. And then you know what happens when it's a CPU, then the CPU ready will go up because they all want to serve I/O. Was that the 10-minute? So latency is the benefit of all flash. So a large impact on application performance is processing time. So reducing latency increases CPU utilization, is what I just said. So we can use more CPU. So you can become more efficient. So maybe you can reduce the amount of servers that you need to run the same amount of VMs. This is one of the benefits that is not always underlined when you put in all flash. People say just everything's going to be faster, but you might be able to have a higher consolidation ratio. So that is one advantage that a lot of people overlook. Then as a best practice, multipathing for an all-flash array is a whole different beast than for what we're used to with a hybrid array or with a disk array. So our best practices overview is you set the flash array devices to use round robin. So the normal VMware round robin is perfectly fine. And the default option is most recently used. That is not optimal. It's most recently used will send the IOPS that way, and then we'll send IOPS that way based on a hash. That's not optimal for a very fast storage solution. Round robin switches logical paths every 1,000 IOPS. So what we recommend is set the IOP operation to 1. That is the lowest you can set it to. So you send one IOP or IO over one path, the other IO to the other path. The reason why we do that is failover time. If one of the controllers fails, you only lose one IOPS potentially, because if it doesn't get acknowledged, it won't be written. So it will be sent over the other path. So you can do very fast failover between controllers. The other thing that we see is that when you run very hard benchmarking on these arrays, sometimes our customers want to say like, oh, I want to see that amount of IOPS. It does give a performance benefit. It's a non-guaranteed performance benefit, but I've seen it. It's like some of my colleagues say I can't say that, but I've seen it in the wild, so it's pretty. It's sometimes like around 10%. So it's not really a given. So I see I got 2 minutes left. So the path failover time reduces from tens of seconds to a few seconds normally, which is very important. You don't want to lose data. You want to move to another controller. When you do non-disruptive upgrades, that is very important. Then also, most recently used as an 100% imbalance on array port. So it will send all this IOPS over one port, and then after a while, it's just going to send some of it over another port. When we set round robin to 1,000, then we send 1,000 over one port, 1,000 over another port. So you will see that the controllers get an uneven amount of IOPS, because you don't always get 1,000 IOPS that is sent. Maybe 800 is sent and 600 is sent over the other one, 200 is sent. So if you send it to one, you have perfect balance over the two controllers. And that is, we have tested that in the lab, and that is beautiful because you get a perfect balance between the two controllers, so you get the optimal performance. So I'm going to stop at the multipathing best practice overview because I only got 12 minutes. So the best option, set the SATP rule. Always set the SATP rule first thing prior to provisioning any storage to an ES6 host. We all know what an SATP rule is. You can set it either via SSH, Power Client, or through the web client. And you can script it for all your servers on your network through a script. Do this once on every host. If you do it on every host and you add a LUN, then it will automatically be set. We can also set it through the web client with Pure, but you still have to set the maximum size from 1,000 to 1. I could go on for another hour, but I think my 2 minutes are gone. Am I right? How much time do I have left? Okay, I'm just going to go over this. What about volume size, volume count, and VMFS density? So it's like the classic question, like, how big can my volumes be? You know, it used to be 2 terabyte, because they couldn't do anything bigger than 2 terabyte VMFS volumes. Now you can do, we got customers that have one LUN, one VMFS data store with all their VDI on it. And the only thing you have to be careful is the LUN queue on that data store, the internal LUN queue. So it's all about, are you using SRM? So you need protection groups on a per LUN basis, then you need different data stores. But otherwise, you can take really big data stores. I got customers that have 20, 40 terabyte data stores, because it's all TIM provisioned anyway. So then you have to look at a VM or a VMFS density. Are you using TIM provision disk or a TIC provision disk? If you use TIC provision disk, you can easily fill up a 40 terabyte volume. It looks like that on the ESX side, but on the back end, the array will dedupe it to nearly nothing. But then you end up with these big volumes with big VMs on it. So the recommendation now is for 6 and 6.5 is to do TIM provisioning for a whole bunch of other reasons, but I would suggest coming to our session later on at 5 that I'm doing with Cody Osterman, and we're going to talk a little bit more about the different disk types and the reason why TIM provisioning is the way to go forward. So I thank you for being here. Great crowd. Thanks very much.